Okay guys, today we're going to talk about finding missing angles, again using SOH-CAH-TOA to help us do that. So we're going to use the trig functions sine, cosine, and tangent to help us find missing angles, of right triangles. Okay. So we talked about SOH-CAH-TOA, meaning it's sine, cosine, and tangent. Based on what legs we're using, kind of helps us determine which SOH-CAH or TOA to use. Now, everything's off of the angle, from the angle's perspective. So when we're looking for a missing angle, let's just start with this. If I was looking for a sine function, if I knew I had information for an opposite and a hypotenuse, if I had both of those values, but I didn't know what the angle was, I would set it up the same way. If I have the opposite and the hypotenuse, I use SOH or sine. So the sine of a missing angle equals the opposite over the hypotenuse. The only thing is if I'm looking for a missing angle, what I need to do is get that angle by itself, and I do that by using what's called an inverse trig function. Meaning, I'm going to take the sine and create the inverse. And it seems super complicated, it's not. All you need to do is take that angle, theta, make sure that it's by itself. You're going to write your equal sign, and then take your sine function and write it on the other side. Except this time, you're going to put a -1 above it to show that it's an inverse trig function. And you're going to take the inverse sign of this fraction. And the fraction goes in parentheses, opposite over hypotenuse. From here, it's just a calculator problem, which I'll show you once we get into the examples. The key thing here, guys, is we have to use an inverse trig function. But it's all buttons on a calculator, so don't get too hyped up about it. All right. So we're going to use SOH-CAH-TOA to find missing angles of right triangles. So as you can see in our first example, I do have a missing angle. There's a question mark here. First thing I want to do, just like I did for any other right triangle problem so far, is I always label my hypotenuse. The hypotenuse is always across from that 90-degree angle. Then I need to figure out what my other sides are. The only other side I have information for is this 12, and to get from my angle to the 12, I have to go all the way across the triangle, so I know that this is an opposite leg. Looking at SOH-CAH-TOA, I can see that it's obvious that I'm definitely going to have to use SOH, because I have an opposite and a hypotenuse. Opposite, hypotenuse. So I have to use SOH. So the sine of my angle theta should equal the opposite, which is 12, over the over the hypotenuse, which is 18. Now remember, I need to use inverse trig functions, which means I take my angle, I put it by itself, I write my equal sign, and then I have the inverse sign to the -1 power of that fraction, which is 12 over 18. Like I said, from here it's a calculator problem. So in your calculator, which I would recommend Calculate 84, it's a great app. In your calculator, first you want to make sure that your mode is in degrees. As you can see here, mine is in degrees. To do inverse sine, you want to hit the blue second button. Then you hit sine, and that'll bring up your inverse sine. See how it has the -1? Inside the parentheses, you're going to include your fraction. Our fraction was 12 over 18. So 12 divide 18. Close your parenthesis and hit enter. This gives you an answer of 41.8. 8103. We're going to just call it 41.8. And because we're finding a missing angle, this is actually going to be 41.8 degrees. I always use theta for a missing angle symbol because it's unique and it doesn't look like any other letter. It's a Greek letter. It's just used commonly for missing angles. Let's take another look. In our second example, I have a missing angle and I have two sides. One of them's the hypotenuse. The other one's right next to the angle I didn't have to go across. So this is the adjacent. Looking at SOH-CAH-TOA, I know that I have an A and an H. The only one with both an A and an H is in the middle, and that's CA or cosine. So the cosine of our missing angle is going to equal the adjacent 4 over the hypotenuse 7. Again, we're going to get this angle by itself. I'm going to write my equal sign. Then I'm going to write out the inverse of cosine and my fraction in parentheses. From here, guys, it's all in the calculator. So I hit the blue second button, cosine, 4 divide 7, closure parenthesis. 55.15. So I'm going to round that up to 55.2. So our missing angle is 55.2 degrees. For our third example, here's my missing angle. My hypotenuse is blank. So then we look for the opposite, which is the one all the way across, meaning 5 has to be the adjacent. Looking at my options, I have an A and an O. The only one with both of those would be here, TOA, which stands for tangent of our missing angle theta, is going to equal the opposite 2 over the adjacent 5. We're going to write our angle all by itself. It's going to equal inverse tangent of our fraction in the calculator. The blue second tangent, 2 divided by 5, closure parenthesis, hit enter, 21.8. So theta equals 21.8 degrees. That's our missing angle. Alright guys, that was finding missing angles of right triangles. Have a great day.